Hello everyone, I am Minendra Surve. Today we are here with a very good and quality question of vibration control. Lot of students ask me this question, and the correct form of this question for vibration control subject is here I have given with you. So you can look at the question. Before going to solve that question, I would like to ask you for this subject vibration control, you need to do various theory questions also along with the numericals also. For University of Mumbai, this is a newly introduced subject, and lot of questions are there. Lot of what kind of question will be asked in the final exam, what kind of numericals will be asked in the final exam. So this kind of numericals will be you can expect it from the university. Before going to solve this question, vibration control is subject for mechanical engineers and in the 7th semester. So you need to start the preparation from the good quality questions, and this question is directly taken from VP Singh book, and this question is unsolved question. You can check VP Singh book and unsolved questions from isolation and transmissibility. There you will get this question. So correct form of this question is I have mentioned here. F of t is equal to 100 n divided by 1000 square cos of 2 pi nt by 60. A lot of questions that students has provided, they have given me a wrong statement or wrong f of t function. They have not provided the function completely. So it is a correct function or correct order of question, and you can solve or you can attempt this question. So we can proceed with this question. So an engine is mounted on a concrete block. So one heavy engine is there, and that engine is mounted on a concrete block which is isolated from the floor. But obvious this heavy engine is isolated from the floor with the help of springs or dampers, and we will look out into the figure also. Again, the unbalanced force of the engine in Newton at n rpm. So n stands for rpm here. Unbalanced force that is provided in terms of Newton, and whenever there is n term belongs the rotational speed or rpm. So this unbalanced force f of t is given in terms of function. So look at that function. F of t is equal to 100 n divided by 1000 bracket square cos of 2 pi nt by 60. This f of t is nothing but usually f of t is equal to f naught cos of omega t. So we usually solve this kind of expressions. F of t is equal to f naught cos of omega t. So whatever is the constant term you will get here after solving this, that is your f naught. And what is transmissibility? We know the transmissibility is equal to, it is a ratio of ft by f naught. Force that is transmitted and unbalanced force. It is a ratio of force that is transmitted to the unbalanced force. So whatever is the unbalanced force, after solving this function you will get f naught at a particular rpm. So here in this question there are two rpms are given. First is 1000 rpm and second one is 1500 rpm. So after solving both the cases, you need to find out what will be the f of t at 1500 rpm. What will be the f of t at 1500 rpm? So this is a complete form of a question. At 1000 rpm is given, it is found that force transmitted to the floor has an amplitude of 100 newtons. So in first case they have provided what is your force transmitted? Force transmitted is equal to 1000 newton at 1000 rpm. So this data they have provided, and what they are asking, determine the amplitude of the transmitted force at 1500 rpm. So amplitude of transmitted force, what is our amplitude of transmitted force? What will be the amplitude of transmitted force that you have to find out in Newton at 1500 rpm. This is the understanding from the question. You need to understand first this concept, and this question is a IAS question, IAS conventional question of 92 batch. So very good quality interesting question, we will solve it. So as I earlier said, a concrete block is isolated from the floor, and this figure is given. If the figure is not given, then also we can solve this question. But for actual idea, you can see this is your engine that is placed above the ground with the isolation. And engine is mounted on a concrete block. So whatever the data they have provided, we'll write that data. First, they have provided an unbalanced force. Okay, unbalanced force of the engine at n rpm. So that unbalanced force of the engine at n rpm, that is given as, in terms of function, f of t is equal to 100 inside bracket n divided by 1000 bracket square, and then cos function is given as 2 pi n t. This is the complete form of equations. Lot of students, they have provided me incomplete question. They have not given this function, latter function cos of 2 pi n t by 60. They have provided only f of t is equal to 100 inside bracket n divided by 1000 bracket square. Actually, you can solve by using that also, but the good quality equation with a errorless or flawless, that is we have taken, and that's why I have searched out, and this question I have found in the VP Singh book and in unsolved section. Okay, so at 1000 rpm the magnitude of force transmitted, that is also given. Particularly this function is a force transmitted, and we can say at 1000 rpm magnitude of transmitted force f of t. So magnitude of transmitted force f of t is equal to 1000 Newton. This is at 1000 rpm, or we can say n is equal to 1000. So this data is provided. Ft is 100 Newton. Sorry, 100 Newton at 1000 rpm. This data is provided. So we'll move forward, and what need to find out here? Transmissibility at n is equal to 1000 rpm. We need, if we found out the transmissibility at n is equal to 1000 rpm, then it will be very easy to move solve further. So what is transmissibility? Transmissibility, we need to find out transmissibility. N is equal to at 1000. So it is f of t divided by unbalanced force f naught. Force that is transmitted to the unbalanced force, and force transmitted is known. Okay, so, or you can say our f naught is nothing but an unbalanced force, or force generated. Ft is a force that is transmitted, and f naught is unbalanced force generated, or force generated. So once you know this, transmissibility is ratio of f of t by f naught. This is a theoretical concept. If you are not studied previously, then go and study this concept. What is the transmissibility, what is force transmissibility, what is isolation transmissibility, what is motion transmissibility, that you have to study, and then only you need to understood what is transmissibility. And transmissibility plus isolation is equal to 1. That some formulas are there, and after reading that formulas you will get easy to understood this kind of question with S. Next, so we will find here f of t is equal to 100 divided by n divided by 1000. We are utilizing this concept, or given data 2 pi n t divided by 60. Now look at it. We need to find out at n equal to 1000 rpm. What will be my value of f naught, unbalanced force at 1000 rpm? They have provided transmitted force 100 Newton, but what is here? Aim is to find out what will be my unbalanced force or force generated due to this rpm. So we need to put n is equal to 1000 in this equation. So if you put n is equal to 1000, so what we will get here? Look at here carefully. If you put n is equal to 1000, 100, n is equal to 1000 divided by this 1000 as it is, square of that, cos of 2 pi n t by 60. So this will get cancelled. What we will get here? 100 cos of 2 pi n t by 60. So this is nothing but f of t is equal to, and this obtained form of f of t we can compare with the generalized form. What is our generalized form? As previously I have discussed with you, f of t is equal to f naught cos of omega t, and omega is 2 pi n by 60. We know that the middle term, this 2 pi n by 60, stands for omega. So what we will get here, force of unbalanced force or force that is generated is equal to, this is nothing but 100 Newton. So once you know this, I will like to ask you, what will be our force transmissibility? What will be our force transmissibility? The force transmissibility or transmissibility ratio, this transmissibility ratio is equal to, transmissibility ratio is equal to Ft by F naught, and this is equal to, our Ft is given already 100 Newton in the given data, and what is unbalanced force we have found out, that is again 100 Newton, so it is equal to 1. Our transmissibility will obtain, transmissibility is equal to 1, and this is a very useful data. So my next question is to you, at what condition our transmissibility is 1? At which conditions our transmissibility is 1? Before going to solve this question, you need to understood what will be the transmissibility in terms of frequency ratio and zeta. So that expression is known to you. If you don't know to that expression, then we cannot proceed to solve this question. So you need to remember the transmissibility concept along with the derivation, along with the expressions, final expressions or final results. So the transmissibility ratio obtained is 1. So now my next question is, if our transmissibility is 1, at which condition we will get? So what is transmissibility in terms of final end expression, that is already known to you, that is f of t divided by f naught, and 1 plus 2 zeta r divided 1 plus 2 zeta r bracket square divided by 1 minus r square bracket square plus 2 zeta r bracket square, and whole is in the under root. So zeta is the damping ratio and r is the frequency ratio here. So at what condition it implies transmissibility is equal to 1 possible only at two conditions. If you know the plot of frequency ratio versus transmissibility, you will get this answer. If you don't know, this is our end results. From end results you can expect the answer. When we will get transmissibility is equal to 1 at r is equal to, this is possible only at two cases. One case is if you put frequency ratio r is equal to 0, then and then only you will get transmissibility is equal to 1, and next if you put r is equal to root over 2, if you put r is equal to root 2, frequency ratio if root 2 1.414, then and then only you will get the transmissibility is equal to 1 for undamped conditions, means zeta, if our zeta is 0, at that cases you will get the transmissibility is equal to 1. But here our engine is in the running condition at 1000 rpm, so the value of r is equal to 0 is not possible in this case. Why? Because our engine is in a running condition, running state of state, so this value is not actual correct value. Frequency ratio cannot be 0 because they have given engine is in a running state of condition at n is equal to 1000 rpm. So we will proceed with r is equal to root 2 in this case. So after getting two conditions, we will nullify the first condition, or we will cancel the first condition, r is equal to 0. By technical it is wrong, and r is equal to root 2 it is correct. So we will proceed with the r is equal to root 2. So we know at n is equal to 1000 rpm, at first case n is equal to 1000 rpm, so just r is equal to root 2, and what is our r? R is equal to omega by omega n, that is a frequency ratio, and this is equal to, so r is a frequency ratio, omega y divided by omega n, natural frequency. So what we will get here, natural frequency omega n is equal to omega by root 2, and omega is equal to 2 pi n by 60 by root 2. So we will put here 2 pi value of n is 1000 rpm divided by 60 and again divided by root 2. This is radian per second. This answer is in the radian per second. This is your omega n, natural frequency at n is equal to 1000 rpm. And the second case is given n is equal to 1500 rpm. So our for this case r is equal to root 2. So for what will be our need to find out at this condition? We need to find out r prime or r dash or r prime. We can use a notation r1 or r prime or r dash, anyone at n is equal to 1500 rpm. We would like to find out r prime is equal to omega by omega n, and omega is equal to 2 pi n by 60 divided by omega n. This is equal to 2 pi, what is value of n here is 1500 by 60, and what is our omega n? Omega n is nothing but this value, that is 2 pi into 1000 by 60 divided by root 2. If you solve this expression, if you solve this entire term, you will get r prime as near about 1.5 root 2, and if you take square of r prime is equal to 4.5. So we have found out here r prime as well as square of r prime. I would like to so why we have taken the square of r prime, I will explain you here. Just take a few minutes. So why we have taken r prime, thus we will take square of r prime. Look at it. So this, after solving this expression, we will get r square prime. So the next statement, or we need to know that transmissibility is equal to what? And if dampers is disconnected, if dampers is disconnected. This, if damper is removed, this is nothing but undamped case. Undamped means our zeta value is equal to 0. Okay, if you put a zeta is equal to 0 over here, what we will get? Transmissibility. Transmissibility is equal to 1 upon, if you put a zeta is equal to 0 over here, 1 upon 1 minus r square. If you and square root will get cancelled, this square and square root will get cancelled, we will get 1 upon 1 minus r square, and just take this mod of this value, because whenever you will solve for any value of r, or r here is a root 2, you will get negative answer over here. 1 minus square of root 2 will get a negative answer. So that's why do not take that as a negative term, just take is at a mod term. So mod term is we will take a transmissibility in terms of percentage, that is a positive percentage, not will take as a negative value. Okay, so if damper is disconnected, system is undamped and zeta is equal to 0, at that case what we will get over here? 1 divided by 1 minus r square. And what is frequency square, or what we have obtained here? R square prime, that is 4.5. Put over here 4.5, you will get transmissibility r square prime. So that's why we have found out r square prime over here, because r square prime generally we have to directly put the value as a 4.5. So after solving this, you will get transmissibility as 0.2857. This is nearly about 30% transmissibility, of transmissibility. Okay, so transmissibility, and what we need, F naught, unbalanced force at 1500 rpm. What will be unbalanced force at a 1500 rpm? So we have the expression f of t is equal to 1000 n divided by 1000, 100 n divided by 1000 bracket square cos of 2 pi n t by 60. So we need at n is equal to 1500 rpm. So similar way, whatever we have used to find out at n is equal to 1000 rpm what is our force generated, similar fashion we can find over here, just putting the value of n as 1500. So what we will get, 1.5 near about 225 cos of 2 by n t by 60, and that is nothing but f of t. And so this is value of, this value is nothing but f naught. F of t is equal to f naught. What is f of t is equal to f naught cos omega t. So this f naught over here is 225 Newton. F naught is 225 Newton. But what they are asked, they are asking us what is force that is transmitted. What is force that is transmitted at 1500 rpm? That we need to find out. Ultimate aim is what they are asking. What is transmitted force at n is equal to 1500 rpm? So transmissibility is found is 0.2857. So this is 0.2857 is equal to ft by f naught. F naught is 225. After solving this, you will get force that is transmitted is equal to near about 64.28 Newton. And this is the final answer they are asking us. So it is a very good quality interesting question. We have solved this question thoroughly with a technically, again numerical wise or some formula wise, we have gained some knowledge, we have gained some concepts, just like to solving any function, or if you don't know f of t is equal to f naught cos of omega t, then it is very complicated. So that's why we have directly taken f naught value as a 225, and in previous case f naught value as 100, and then we will get 100 by 100 transmissibility is equal to 1. And when transmissibility is equal to 1, that again a very good concept. Transmissibility is equal to 1 in only two cases. Frequency ratio is 0 and frequency ratio is root 2. So why we have not neglect, why we have cancelled out frequency ratio r is equal to 0 value? Because our engine is in a running state of condition. So that's why we have neglected r is equal to 0. We have come up with r is equal to root 2, and after proceeding r is equal to root 2, we have found out what will be my new prime. R prime is 1.5 root 2. So after putting this value of r square prime, we have found out new transmissibility is 30%. And actually, if you look out the such a kind of engine, if you isolate such a kind of engine from the ground, we need a transmissibility as near about 30%. And this is a good quality question. And questions itself suggest we have practically made the conditions. Again, so for solving this, they are asking us what is force that is transmitted at 1500 rpm, and that is found at 64.28 Newton. If our force that is transmitted is 64.28 Newton, that is the final answer. So if you have any kind of doubts related to vibration control, you can text me in the comment box. You can ask me any questions, or you can ask me any kind of numericals from vibration controls. I will try my best to give you answers. I will try my best to solve that questions. And if you like this content, please subscribe us and please comment us. Thank you very much.